Although we're not really into organic reactions yet, I'd like to take some time and just show the mechanism for our generic acid-base mechanism, or our acid-base reaction. So here's our acid, our good friend acid. We've seen that molecule many times before, and this is going to react with water. Now, I'm going to show water with a couple lone pairs. Water is going to serve as our base, and it is going to remove the proton on our acid. And the way we show this is with a mechanism. Now, mechanisms track the movements of electrons. So mechanisms are about electron movement. Now, if you understand electron movement, you also understand how bonds are going to break and form and how atoms are going to be connected. So it's easy to think I'm going to show a mechanism so that I can keep track of the atoms and where the atoms go, because that's what we tend to draw on the product. However, the mechanisms are about tracking electron movement, which then shows us where the atoms are going to be. So when we draw a mechanism, we are moving electrons. And so we show electron movement with arrows. And those arrows start where the electrons are. And, water has 2 electron pairs. So we're going to start with a lone pair. And that lone pair is going to interact with that hydrogen atom. Now, how many bonds does hydrogen typically make? It makes 1 bond. So what we're showing with this arrow is that this lone pair is going to go from being a lone pair to a bonding pair. And it is going to form a new OH bond. Well, if this hydrogen, which already has a bond, if it's going to form a new bond, it's got to lose an old bond. And that bond is represented by this bonding pair. And where do those are 2 electrons in that bonding pair. Where are they going to go? They're going to get stuck on atom A. So when we draw the product of this reaction, we are going to show A is no longer going to be bonded to hydrogen. And in fact, our mechanism is very clear on that. This arrow represents how the bonding pair is being broken and being put on A. So we haven't been explicit about this in the past, but A, we've always said it's A minus. Well, atom A is going to pick up another lone pair. That lone pair came from the HA bond in the starting material. Now, and here is our conjugate base. So we've given the conjugate base now with a little more detail. And we won't typically show these lone pairs on A because we're not being specific about A. But if you want to show a mechanism, we need to be clear about this what happens to this bonding pair, and the bonding pair becomes a lone pair. Now let's deal with our water. Our water base has now plucked off a hydrogen from our acid. And so in the product, the oxygen that we see in our base will have 3 bonds to hydrogens. Now, I'm going to draw out the full structure. There are 2 of the bonds, and we could say that these 2 hydrogens maybe are these 2, the ones that started on the base. But now we're going to have a 3rd hydrogen bond on our OH bond to our water, what was simply water. And one of our lone pairs is gone, so we'll only show 1 lone pair here. Now, if we go through the rules for formal charges, we'll find that oxygen has a positive charge, and this is now our conjugate acid. And what we've done is we've shown the complete mechanism for this reaction. Note that by tracking the electron movement, all these arrows, that arrow and that arrow, are tracking how the electrons move. But once we know how the electrons move, we can say what happened to the atoms and place the atoms correctly in the product. Let me show one really common mistake. People, when they show mechanisms, will forget that they're tracking electrons, and they'll instead track atoms and say, oh, I want this hydrogen to go to that oxygen. And they'll somehow come up with the products like this, which are incorrect because They move the atoms, not the electrons. But this is a really common mistake. To use your arrows to move atoms. If you can avoid this one mistake, your mechanisms will be far easier and be far more consistent, and they'll be correct. So just remember, we are moving electrons. Now once we move the electrons, the atoms are going to have to change as well. But we're moving electrons, and so our arrows start with electrons. Where are the electrons? They're either in lone pairs or they're in bonds. So our mechanism arrows always start with lone pairs and bonds. We'll see a lot more mechanisms later in this course.